automatic thing. It's 3 years. Vaughan corrects me. Thank you, Vaughan. He, while he was studying, he was also an undergraduate apprentice with BAC, British Aircraft Corporation, in Weybridge. And I think
it's a museum. It's a museum now.
But I think I visited there when they were building the first short takeoff and, well, basically vertical takeoff planes. Were you involved in those? No. Anyway,
big fast aeroplanes.
It was a very interesting experience because the factory was virtually doing everything by hand. And it was a really tailor-made aircraft, very interesting. And I'm sure Vaughan enjoyed that period. He then became an engineer, mechanical engineer with Mott, Hay and Anderson, which is now Mott MacDonald, and spent 5.5 years there doing engineering of a serious nature. The following 30 years were spent with Lloyd's Register of Shipping. That was until a few years ago. I think I'm not going to say too much about that. He ended his career as a technical director for the company. And I must say, I was at one point a beneficiary of Lloyd's Register when they supported a course at the University of Birmingham. And that was a very, very good thing to do. He then spent another 5 years as an independent consultant in maritime and safety. So I think it was probably mostly safety. Fair to say? Yes, he nods. He's also a visiting professor at the University of Southampton, and he's been that since 2004. So this is his 21st year, I understand. Vaughan was my predecessor as president of the Newcomen Society, and he had a huge impact on the governance of the organization. He improved it no end. He's a fellow of the Royal Institute of Naval Architects. You're the second naval architect I know. The first one was a PhD student of mine. I think it's a wonderful profession. He's a fellow of the Institution of Mechanical Engineer, as I am, and is a fellow of the Institution of Marine Engineering, Science and Technology, and he's an honorary vice president of that society. So it's a very illustrious career, and I think the contribution which Vaughan is intending to make today is about maritime regulation. Is it the force for good? Of course, it's not just maritime regulation, it's all sorts of standards which have a very big impact on society, on engineering, on technology. And lots of engineers think of them as enemies. Standards are bad, regulation is bad. I entirely disagree. And I hope that Vaughan will make a very good case for regulation.
I'll use that one. Thank you, Felix. This presentation is a combination really of things I've done over the years, but it was put together because when I went and worked for Lloyd's Register, I was leaving behind a career in design, construction, manufacture. And suddenly you find yourself in an organization where you seem to be the other side of the fence, stopping people doing things. And I remember my father said, well, is this very sensible? You know, it's all a bit negative, isn't it? And I thought, that's interesting. And then various other people said something similar. And I thought, we seem to be doing things that are worthwhile, but general consensus regulation, as Felix has said, that it's necessarily bad and unnecessary. Well, we'll try and show that that probably isn't the case. That's the theory anyway. That's the direction I'm heading. But if you think back at things like Grenfell Tower, and you think, where is the problem? There's plenty of standards out there, but nobody enforced them. So it needs regulation, needs enforcing, standards need enforcing. And yet we have a crowd of people around the world who think all regulation is bad. It should be thrown away because it stops people doing things. I would argue it stops them doing things that would be inherently rather stupid. Let's start with the importance of shipping to us. Theme Metropolis, when he was the Secretary General of the International Maritime Organization, used to say, without shipping, one half of the world starves and the other half freezes. And that's pretty much the case. We're shipping around vast volumes of stuff. Over the last 60 odd years, that's gone up by a factor of 10. We're now shipping something like 12.5 billion tons of cargo a year. So that's quite a lot, really.
Putin and Trump met at that summit in Alaska
Now,
2
this
months ago. It's been
here is
decided there's no
an
need for them to meet. The Secretary of State, Marco Rubio,
it's leaving London Gateway and heading down the river out to the sea. The next stop is Tangier. That has on board 157,000 tons of cargo, something like 14,000 20-foot equivalent units. Now, if you put that together, I reckon that's 69,000 lorries. And it's moving at much the same speed as a lorry, really, isn't it? It's and it'll keep on going that as it goes around the world. That ship is 368 meters long. So if you take it outside from here, you drop the aft end down at Barbican Station, and the bow is somewhere the other end of the, whatever the small hall is at the end of Smithfield Market. And it's about the same beam as those halls are wide. So that ship is 51 meters beam. So that's a big bit of metal floating around the ocean. And that's essential for all of this globalization, which we think of as being terribly important, or perhaps not, as how we work. Now, when you look at that, where are ships owned all over the place? Where are ships registered? And this is important from a regulation point of view. We have these interesting countries which the ships never visit. Very few ships end up in Monrovia compared with the numbers that have Monrovia painted on the back end. Marshall Islands. Interesting. So you look at that, and before you get to a ship-owning country of any size, which is Hong Kong, you've already dealt with well over half of the world's fleet in the flags of Liberia, Panama, and the Marshall Islands. So that's the sort of world we're operating in. Some would say it's a bit outlaw. And what we're dealing with all along is, of course, it's a commercial business. And this is a graph of what's known as the Baltic Dry Index, one of those things we used to look at in Lloyd's list every morning to see what's happening with freight rates. And you think if you're operating in a world where for a long time your freight rate is down at the bottom there, and suddenly you get a big spike like that, it's a difficult place to be operating ships at all, let alone trying to do it safely. Sometimes you have a great grin on your face, and sometimes you'd rather be doing something else. But safety regulation is quite old. There's a lot of notes which suggest it starts in roadie and sea law. I can't find anything, and a lot of other people can't find anything. There are mentions about things about overloading, but no guide as to how you determine what overloading is. I guess it's when the water comes over the side. And the regulation I'm talking about here has two components. One is by the state or states. That's classic, saying you can or cannot do things. And then a self-regulation, which is by the community, for the regulated community through standards, codes of practice, and so forth. And I'm going to sort of merge those together because that's what we're dealing with. And the system as it sits now looks like this. At the top, there's a thing called the United Nations Convention on the Law of the Sea. That's the overarching convention. It won't surprise you that the United States has never signed that convention. And then underneath that, you have a collection of national administrations, in our case, the Department for Transport, the port states, and then you have the International Maritime Organization, United Nations body, the International Labour Organization, various standards and organizations. These things called the classification societies, some which are working generally as recognized organizations on behalf of flag states. And then this little diamond, which is the European Union, which has an enormous influence over shipping. So that's the various blocks we're looking at. And the history goes back to about here. Lloyd's Register was founded in its earliest form when these ships were building. The Victory was constructed at Chatham in 1765. Its completed began in 1759. The Endeavour was built in Whitby in 1764 and was actually a commercial ship. It was a collier. And the first volume of the Register of Ships was put together by a group of basically underwriters who wanted to have a measure of what they were insuring. It's a very novel concept for insurers to want to know what they're doing. We always used to think it was a bit like Ladbrokes without the form book. But here you were, and they instructed surveyors to go and look at ships and to give them a class to determine whether they were A, E, I, O, or U, and to grade the outfit, in that case, the rigging, good, middling, and bad. And so you were actually, this is where classification comes from. You were classifying ships by their standard. Now, of course, the ship owners didn't like the underwriters' register because they thought it was all very biased. So they formed their own register. That came along 1798. 1834, there's a bit of a rumpus, and really it was all too complicated. So the two registers combined and formed what is known as Lloyd's Register of British and Foreign Shipping. You know, think stamp album, British stamps, foreign stamps. And they first published what were known as the rules and regulations determining how you classed a ship. So at that point, you suddenly started getting a standard produced by this strange body, which really had no corporate form until quite recently. And that introduced, among other things, a rule for freeboard, which was how much load you could put into a ship before you overloaded it. Now, in 1841, life had got more complicated, and the Liverpool ship owners got upset about Canadian-built ships being classed downwards. And that intrigues me, because at that stage, we have family-owned ships that were being built in Canada, but were actually classed Lloyd's Register, although registered in Liverpool. But the Liverpool owners were upset. They set up a Society of Liverpool Registry Book of Shipping, and that used the Lloyd's rules, which is kind of interesting, until it ceased publication in 1845. The Liverpool issue resurfaced with the treatment of iron vessels, and they took a view that the Lloyd's Register might have been very good at dealing with wooden ships, but they really knew nothing about these new iron ships, and so they formed a register of iron ships. And that went on really until it eventually merged with the Register of Shipping. So Lloyd's Register was gradually pulling in all these little local organisations that were set up for probably quite good reasons. But that did force along the speed of developing the rules for iron ships. There was also a thing called the British Corporation, which was set up in Glasgow in 1890 because Scotland was different, and was merged with Lloyd's Register in 1948. And after that, the British end had Lloyd's Register. This is a bit Anglo-centric, and that's quite deliberate, because really until after the Second World War, Britain dominated merchant shipping in both terms of building and owning. And so Lloyd's Register and its various elements are quite central to that. Now, they were thought as being important. These are two slips out of the Liverpool Mail and Liverpool Mercury. The brown of that is the relative up the tree. And you will see that to encourage people to use the ships, you make it very clear it's classed A1 at Lloyd's. And so that was seen as being important enough to put in your adverts. And the Mangerton was one that was built in Canada. Now, in 1850, a big change happened because the Marine Department of the Board of Trade was formed. Until that point, the government was very laissez-faire about shipping and a whole pile of other things. And by 1850, there was a pressure that said, these things are not as safe as you would like them to be. And they gave the Board of Trade the power of regulating two things, railways and shipping. And the big element was shipping. And the big change came in 1854 with the Merchant Shipping Act, where interestingly, one of the major changes was changing the rules for calculating tonnage. Tonnage is terribly important, but in my view, terribly boring. It's about a calculation of a volume of the ship, sort of implies the earning power of the ship, and it's used basically for any charges you levy for port dues, harbour dues, regulations. So it's a way of extracting money from the poor ship owner. That was all dealt with by the Customs and Excise, of course. So the early Merchant Shipping Acts in the 18th century just required ships to be registered with a customs house. By 1850, you got a marine department set up, and it was moving away from laissez-faire, although it was taking its time about that. Now, the change of the tonnage calculation is significant because that remained the way of the Mawson method, became the way of calculating tonnage until the 1969 tonnage convention was put. So it was there for a very, very long time. At that, there were 26,000 British registered ships. Now, this is the bit from the Assistant Secretary of the Marine Department. It's only been in existence for 6 years, and here he says, there can be no question that government interference is not only unnecessary, this is the guy who's been told to do it, but may really become vicious if it attempts to attain an end by official inspection and supervision that can be better attained by the development of a free and healthy competition, and by the self-interest and emulation of the trader. That's kind of interesting because you can sort of read that into a whole pile of thoughts about whether or not you need regulation in other industries. But of course, the thing that everybody has in mind is, well, of course, there's this man Plimsoll comes along, who was a coal trader. Actually, he moved most of his coal by rail and was very much involved in the coal drops at King's Cross. But he's remembered for the Plimsoll line. And on the statue on the embankment, there's a lovely example. You will notice on what my daughter refers to as the bus stop on the side. There's two letters, it has L and R. They stand for the assigns the load line. So if it says LR, it's Lloyd's Register. If it says BV, it's Bureau Veritas. But every single book I've got that shows you what a load line looks like always says LR on it and never tells you what it is. So there you are, that's the load line. And at that stage, there was a lot of work done on what were referred to as unseaworthy ships. And here you are, 1874, so just after Mr. Plimsoll had produced his pamphlet, which is about an inch thick, where he asked a question about what the Board of Trade was doing. And surprisingly, when you think about it, since he was really talking very much about overloading, the number of ships detained for overloading was 22, all of which had a bit of coal or whatever taken out and they were okay. But at the same time, 294 ships were detained for survey on account of the defects in their hull or equivalent. That's a lot, but there were 26,000 ships at risk. Now, this is some interesting work which talks about that and is relevant, I think. Tim Carter has done a lot of work. We exchanged a whole pile of things. I gave him a whole pile of casualty reports, which he's been stripping stuff out with his colleagues. And this is one that he put together, which is actually showing that until about 1900, there were more people lost each year shipping coal than there were mining coal. So shipping was a cozy occupation. Board of Trade return, which is an annual sort of publication. This is lives lost on British registered ships. If you ignore the dotted ones, because they're sailing ships, not that they're not important, but they're becoming less important around the turn of the 20th century. And you look at the steamships, and you look at the loss of passengers and seafarers, when you lose passenger ships, you tend to lose large numbers of people. So here you've got, in 1895, it's a ship called the Kaohsiung, which is shipping Chinese people during the wars in China. Drummond Castle ran aground off Ushant in 1906, 1896. The Kamorta sank in a cyclone in the Bay of Bengal. And then the one that makes the big change to a lot of them is the one on the far right-hand end, which is 1912. And 1912 is the loss of the Titanic. So that graph I find is quite interesting because the return for 2013 shows that. And the loss of the Titanic, and we can argue a lot about whether that's about the ship design or the people driving the ship, is that it led to the Safety of Life at Sea conference in London, which eventually starts the idea of producing international or internationally accepted regulations for shipping in design. And that covered things like subdivision, double bottoms, whether you had a certain amount of astern power, which would have been quite useful for the Titanic, radio telegraphy, life-saving appliances. And the first load line convention, which came out of that, which was looking at bulkheads, particularly Bulkhead Committee, was adopted in 1930. So life was not moving terribly fast. That was nearly 20 years afterwards. And that was about the principle of having some reserve buoyancy. And yet, this is Titanic, of course, and what you get in the casualty returns is this one line, just like there is for everything else. So when you're looking at this, the casualty returns I've got run from 1890 forward, long lists of ships that have been, and I'll come to some of those later. Now, moving forward, there are a couple of little minor disagreements around the world which get in the way of a lot of the progress of this. And in 1948, of course, we're just into the era of the United Nations. And one of the things in 1948 was that there was a conference called in Geneva by Britain, major ship-owning nation, which set up the Intergovernmental Consultative Organization. And that was intended to form an international regulatory body, in effect. 32 nations sent delegations, nothing surprising in any of them. 4 nations sent observers. We were beginning to see intergovernmental organizations and non-governmental organizations there. And the first task given by the conference was to establish this organization and to revise the SOLAS convention that had been started just after the Titanic was lost. So it was a 48 edition of that. That eventually was modified to form SOLAS 60, SOLAS 1960, but that only entered into force in 1965. So that's 54 years after the Titanic was lost. Things can move fast. Now, the conference was convened under the United Nations Economic and Social Council, and it eventually started looking at what they should do. One was called a Safety of Life at Sea conference to be held in London in April 1948 to consider amendments to the 1929 convention. So IMCO was set up. It first met in London in 1959. It still meets in London. Its home is in London, the only United Nations body that has its home in London. And it concentrated really on safety, so load lines, carriage of dangerous goods, measurement of tonnage. And then after one of the big incidents I'll come to a bit, Torrey Canyon, the prevention of marine pollution. So you have this umbrella convention at the top, the United Nations Convention on the Law of the Sea, and that requires under Article 94 that the flag states effectively exercise its jurisdiction and control over ships flying its flag. Now, this is the sign up to the IMO, the 196 nations in the United Nations, I think. 176 members of the IMO. And it surprises a lot of people. It's very international. The Secretary Generals have been, the current one is Panamanian, previously South Korean, Japanese, Greek, Canadian, and Indian, and then some Brits, of course. Now, Eswatini is not in that list of people that have signed up to the IMO. However, it has been seen painted on the back of some ships recently because they're part of this dark fleet, which is currently causing a lot of concern, all the sanctioned crude oil from Russia and Iran. So it is something of a wild place out there. But along the way, we have this sort of problem. We've got classification developing on its own world over here. We have the statutory regulation, which is done through the IMO, and the IMO standards only become law when they're implemented into the laws of the flag states themselves. So the convention has no authority in its own right, but it has become the stage where there is a mutual duality. SOLAS requires a ship to be built in accordance with the standards and survey of a recognised organisation of the flag state, a classification society, and the class rules require that it carries all the necessary international certification. And certainly the thing when we did that with the Lloyd's Register rules, we got very concerned about these things called third-party statutory certificates. That's organisations which we didn't think were capable of doing the statutory certification, so we just wouldn't accept their certificates. There are 40-something recognised organisations at present, of which 12 are members of the International Association of Class Societies. And some of the smaller ones are struggling. But this is the link. The class rules provide the requirements for a lot of parts that are not in the convention. So there's not much detail in the convention about strength, machinery, and so forth. But they all have a tie-in to the big conventions. SOLAS is safety of life at sea, MARPOL is marine pollution, and load line is what it says it is. And there's more. So there is this cross where you have to make sure that your class rules do actually satisfy the requirements of meeting the statute. And then we got this thing which is now called goal-based standards, where there was a work plan proposed by the Bahamas and Greece, one flag state, well, two flag states, looking for more robust ships. I'll come to the reason why a bit later on, but the IMO did not want to develop an equivalent to the class rules. The class rules are expensive. When we developed jointly the common structural rules, I guess we must have spent upwards of 30 million across the societies developing a set of rules for oil tankers and bulk carriers. And IMO looked at this and said, well, the only people with the knowledge to produce these technical rules are the class societies. So we want a way of sitting on top of them and making sure they do what we want them to. So the SOLAS rules now have a requirement called goal-based standards, which only really affects these high-risk ships. That's big oil tankers, more than 150 meters, and bulk carriers above 90 meters. So those ship types were seen as being high risk. Interestingly, not passenger ships. And the goal-based standards basically set the high-level goals of what you're trying to achieve and the functional requirements and how you verify that the rules actually deliver that. And then the class societies produce the requirements of more detail. So this is where we are, back to here. And now we can talk about more interesting things. In practice, it works because the national administrations, the flag states, and the port states, of course, they're also port states. Port states goes back much further, if you remember, because we had the Customs and Excise looking at ships and then the Board of Trade. And that's got renewed emphasis because of some of the things that have happened. The port states are now doing their own inspections and have the power to detain ships. The flag state can detain ships. The class societies do not have the power to detain a ship, but you can make a phone call and get it detained usually. So there are ways of making sure that ships which are not fit to go to sea are tied up. Now, the national administrations have implemented the international conventions into their law to make them legal. In our case, it's all done through the Maritime and Coast Guard Agency and the Department for Transport. Goes into the Merchant Shipping Act, which was revised in 1995, at which point it took the 1895 Merchant Shipping Act and the amendments thereto and consolidated it. So the marine legislation takes a long time, but it's a very, very large piece of legislation. I think it's the largest single piece of UK legislation is the Merchant Shipping Acts. And it covers all sorts of things as well as the ship itself. It covers things like paying the crew, covers the qualifications of seafarers, covers pension arrangements, and it covers the way you take money off ship owners, among other things. Now, the class societies now generally act as recognised organisations on behalf of the administrations. My old organisation currently has agreements with 110 different national administrations to issue certificates on their behalf. And the 12 IACS members currently class 94% of the world and around 78% of the world's ships. So what isn't classed by the big class societies is small ships, generally on coastal service, and most of the big ships are with those 12 societies. So you've got 174 flags out there, but only 12 class societies. What you're dealing with is this. There was supposed to be some noise, but there isn't. No idea why. We'll give that one up. But if you look at what's going on here, this is a very large oil tanker. So 200 and something meters long. You can just about see the mast on the foredeck. This is downhill in the typhoon or close to typhoon. Yeah, there's a fall. And that's the sort of make ships working. That was actually in ballast, so relatively high out of the water. But by the time it got to the other end, one of the anchors had disappeared. And the ship was looking a bit the worse for wear. And these are pictures of a ship called the Ben Kraken. It's one of the fast cargo ships. Hit a large wave off South Africa. Now this one bent. But the Neptune Garnet, I think it was on the same sort of voyage pattern, and that lost all forward of the first container bay. So the sea is a pretty unforgiving place. And when you get things like that, then the class societies generally will do something to stop it happening again. We don't get much of that these days, but we do occasionally get ships break up. This is the one that delivered BMW motorcycles to Dorset. This is the MSC Napoli, which had a big split just forward of the engine room bulkhead, and was beached in Dorset. And ships are quite fragile. I have used occasionally, I decided I wouldn't do it here because I thought people would not appreciate it. A bag of flour is quite good as a demonstration because if you take the cross-sectional area and the thickness of the bag, it's very similar to the ratio of the thickness of the cross-sectional area on a big oil tanker. Oh, that's a different material and it's not stiffened and all the rest, but yeah, they are very efficient uses of material. One that we got involved in is quite interesting. We had a very bad explosion in 1947 on a ship called the Reina del Pacifico, which was an explosion in the crankcase of the diesel engine. It killed 28 people in the engine room. And after that, there was a lot of work done on dealing with these things here, which is the explosion relief valves on the crankcase. Now these are supposed to lift to take away the pressure and stop the crankcase blowing apart, but to reseat to stop the flame from the explosion coming out into the engine room. They were introduced after that explosion, and we went for many, many years without really getting bad crankcase explosions. It's all about oil mist in the crankcase, and so there's oil mist detection to try and work out when you get the oil mist there, and then something hot sets off the oil mist for an explosion. And in 2000, we had a very big container ship, had a very bad crankcase explosion. It didn't kill anyone, but it did there weren't any people in the engine, of course, which helped. But what happened was the valve lifted and dropped and didn't reseat. And that was because the valves had become so big that the sheer weight of this thing when it lifted was it just dropped and wouldn't close properly. And we found that they were being tested in a horizontal position like this. And so the change we made very quickly was that they should be tested in the position where the valve is vertical. And then you can make sure that if it does lift, it does reseat, and didn't have any more after that. Passenger ships always get interesting. This is the ferry, the Scandinavian Star, which caught fire on a voyage in April 1990. It was actually caused by arson on a stairwell. The first attempt was put out, and so the arsonist went and tried it on a different stairwell. It killed 159 people. I remember going down with some colleagues of mine, and we were testing the alarm systems to see where it could be heard. And all you saw on the floor were the outlines of where people had died. Interesting. But what that really threw up was that most of the people died from either cyanide or carbon monoxide poisoning. Part of the problem was dead-end corridors. So people were trying to escape, but suddenly found their pathway blocked. There's a question about whether fire alarms were audible, which is what we were trying to work out. And the problem was, enormous changes on the materials you could put on ships. So a lot of the decorative panels were plastics of one form or another. And when they get hot, they develop some nasty poisons. So there's a lot of work came out of that around finishes and so forth on ships. This one you may or may not remember. This is the Costa Concordia. Went a bit close to an island, took a big rock in the side, drifted off round the bay, got blown back onto the shore. And I've always had a theory, if the wind was blowing in the other direction, you would have killed a lot more people, and it may have had a lot more attention, but it still killed 30-something people and cost an awful lot of money in salvage. But basically a factor of human error or overdoing it in that case. And if we look at the graph, this is some data I pull out occasionally. This is from the casualty returns, looking at the number of passenger lives lost in sort of, most of these will be my working span, which is what I thought was there. The big one there is ferries in Africa. The big ones are ferries in Africa and ferries in the Far East. Generally, it's pretty safe for passengers. If we look at oil, this is more interesting because people get very worried about oil. And that's what you get when you build them. They're big structures, lots and lots of welding. And sometimes they break. This is the energy concentration in Rotterdam, which just broke because it was unloaded in a rather poor way. You take the cargo out of the middle first. This is what happens. You can break these ships quite easily. Oops. Torrey Canyon. That's our sort of memory span, I guess, and that's what set in place a lot of the work at the IMO about reducing marine pollution. That was really taking a shortcut to get over the tide into Milford Haven. Exxon Valdez, Alaska, linked 37,000 tons of oil. John Brown, who was running BP in Alaska at that time, said, well, it did make us think that compliance was probably a good thing to do with regulations. But what that did really was it brought about some quite important regulation in the States, which was local, and local regulation is not helpful within international business. Local regulation is more of a pain than you'd think. And this was that the Americans wanted to go to double hull oil tankers. So you're moving from a single hull, one sheet of steel between the oil and the ocean, to go into a double hull. This is the Brer, which ran into Shetland. After the engine stopped because they got water in the fuel. Diesel engines don't work on water. And so they were drifting and went off there. This is when we get into the European effect. There were two ships, the Erika and the Prestige, which broke up. They were old single hull oil tankers. One was Maltese flag, one was Bahamas. The Bahamas was why the Bahamas got behind more robust ships. The Europeans forced through some legislation which accelerated the phase out of single hull tankers. So suddenly the industry was faced with a whole pile of tankers you couldn't use anymore, except in places which didn't have much enforcement in place. And it also brought in what was called SOLAS Chapter 12, which is around enhanced surveys. So there's a lot of work done on much more intensive survey periodically. And that was around close-up survey and thickness determination. So a lot of work for ultrasonic companies to measure thickness of plates, to work out how bad the corrosion was. And the other was, when you talk about close-up survey, we're talking about more or less arm's length. So accessing these big structures is a lot of work. So that was Prestige. But when you look at what's happened with the oil industry, a lot of this comes down to changing and improving rules and standards, changing and improving survey rates, but also about the oil companies deciding that it's our cargo. Doesn't really matter whose ship it is. If it's a BP cargo or a Shell cargo, the headline will say Shell dumped another load of oil. So the oil companies as the charterers got behind this with a lot more in terms of the vetting of what they were prepared to charter. This is the big oil spills in terms of thousands of tons. And you think, well, it's improved. It's improved a lot. And that's why I think self-regulation, regulation, etc., does clearly deliver. And if you look at that, that's an interesting curve because it shows you how much oil is now transported compared to what there was at the beginning of that period, and how the amount of oil that's been dumped in the ocean has dropped. And you think, well, if a lot of other industries had had that sort of improvement, we'd be quite pleased, really. But this is a comparison of the tankers lost. So on the left, it's the loss rate per 1,000 ships at risk. And you're comparing there the bulk carrier with the oil tankers. And you can see some areas where the bulk carriers were definitely ahead in the game. We had some very bad losses in the early 90s and then later on in the late 80s and 90s of big bulk carriers disappearing. So bulk carriers, carriage of cargoes in bulk. What do we talk about? We talk about coal. We talk about grain. We talk about iron ore, bauxite, those big bulk cargoes. There's two ships there loading. If you're clever, you can see one over here. And there's the one here. This one is called D. Duckling. I kid you not. The owner had these ships where he'd have a whole fleet. So you've got A duckling, B duckling, C duckling, and D duckling, and so forth.
Is that Narvik?
Hmm?
Is that Narvik?
That's Narvik, yeah. And the other one at the end of the jetty, I'll show you a picture of it. SAC. So you're loading iron ore there from Sweden at something like 10,000 tons an hour. At some of the ports in South America, you're now being forced to take 20,000 or more tons an hour into a bulk carrier. So you're not treating these ships terribly kindly. That's a hell of a rate for dumping iron ore pellets into a hold. So that's the ship that was loading at the end there. A Coble fret ship. Is quite low in the water, down to a marks more or less, 175,000 tons of iron ore in that ship. And it's loaded in alternate holes. It's only loaded in holes 1, 3, 5, 7, and 9. The reason being, if you load it homogeneously throughout the whole ship, the center of gravity is much lower and the ship becomes very, very stiff. It's better if you don't load it in that way. The holds aren't full, of course. If you fill the holes with iron ore, it doesn't float. So you will fill the holes when it's got grain on, but this has got iron ore in alternate holds. Now, if you take that ship and you jump it down outside, the bow is at Barbican Station, and the stern is down the far end of the markets on the third market hall, whatever the poultry hall. Big ships. So that's, as you say, just leaving Narvik. And when you unload them badly, you can break them alongside, that's alongside pier number 2 at Taranto. And you break the ship. Jolly difficult to salvage. But what we were finding was that when you only have part of the hole filled and you then put water in the rest of the hole, you seriously overload the ship. And in one case there, you've got some sloshing of water, which has damaged the bulkhead. The other one is where the side shell falls out. And what you are getting inside the holes is this is the stiffeners on the side shell of the bulk carrier. And they're suffering from corrosion. Well, they will do when you're carrying things like coal because of the sulfur in the coal. Sulfur and a little bit of water. And the other thing is you've got to unload these bulk carriers. They can be loaded from a conveyor system very fast, but to unload them, it's all done with grabs. And when you're waving around a 50-ton grab full of iron ore, then parts of the structure are quite vulnerable. And so you had this problem of damaging the structure. Part of the changes now is dealing with coatings. So the modern coatings are much better at reducing corrosion, even in this sort of environment. Let's face it, you're dropping in there quite big iron ore pellets on top of the coating. Sort of like taking a car through a rain bath. But a lot of work was done on those. We did a lot of large-scale fatigue tests. The only place you could find to do this was the Krylov Institute in St. Petersburg. But very large models we did tankers and bulk carriers to look at the fatigue properties of some of these structures and redefine the way we had the structural rule. And then we went back to this ship. Now, this sank in 1980. It's one of the first things. The thing I used to do every morning was pick up my copy of Lloyd's list as I went past the desk in the foyer. And you opened up and you looked at the casualty page as you were looking to see whether it was one of our ships that had sunk and the freight rates and things like that. And this was one of the first I remember noticing. This is a Derbyshire, which is a Bibby-owned bulk carrier. Well, it's actually a combination carrier. So it was designed to carry either oil or bulk cargoes. So it's a compromise. And that ship sank when she was only about 4 years old in 1980 off Japan, carrying iron ore from Quebec. And it basically disappeared. There's a lot of pressure from the Families Association because they believed the ship was badly designed. There was a lot of concern about frame 65, which is basically the frame at the aft end of the cargo block, because there was a possible misalignment between longitudinal members based on some of the sister ships. They had fractures in that area. So it was all about frame 65. There were inquiries, and then there was an attempt to find the wreck. In the days of Woods Hole, finding the Titanic and the Bismarck and so forth. And they found the wreck. And then we had a reopened formal inquiry, and it determined that what actually happened was the ship lost a small hatch cover up here, and the ship started flooding forward and gradually went nose down. And then the hatch covers were seeing much higher loads of water on top of them in a typhoon. And you could model it and say, well, that's plausible, and it looks like the wreckage, because what was found, you find the name on the back of the ship, which is always a good hint. There's a hatch cover on the left there. There's the bow of the ship at the bottom left. And there's the hatch with the little rope coming out of it. So it had gone a long time before it sank. And out of that, there were some recommendations that I guess the inquiry report came out in the early 2000s. I remember sitting down in my hotel room and writing the proposal for the action by IACS. And it was things like putting a focusal on. Focusals are gone because they were expensive, but they're very good at providing buoyancy forward. Strengthening the foredeck fittings, because a lot had taken heavy weather damage up there. Looking at hatch covers and whether hatch covers should be strengthened. Strengthening bulkheads, putting water detection forward so you could tell if the forward spaces were full of water. And then a way of dewatering the forward spaces without going down to the foredeck. And all that got put in place quite quickly. And that included going back and retrofitting existing ships. If you think in terms of strengthening bulkheads on existing ships, that's an expensive task. But let's look at the bulk carriers now. The number that founder, that's basically disappear, is doing a lot better than it was in the area where we started getting concerned in the 90s. The number of lives lost has dropped. So that's bulk carriers. If we look at this, this is just a local diversion. This is a ship called the El Faro. Now, the United States still has this thing called the Title 46 CFR, the Merchant Marine Act of 1920, the Jones Act, which says that all US cabotage trades must be carried out on US-owned, US-built ships. Most of them are quite old. This one was sailing Jacksonville to Puerto Rico. Not an international voyage. Was in the Bermuda Triangle at the time. And it sailed into Hurricane Joaquin. Now, we know quite a bit about it because of finding the data recorder. Now, there was an emergency call by sat phone from the master saying a scuttle had blown in, the hold was flooding, the engine had stopped. So life was not good, and we were in the eye of a hurricane. He was using his own version of weather forecasting, which is probably not wise. How do we know where the ship was? Well, 33 minutes after his phone call, the US military hydrophone system, because this was in the middle of their underwater testing area, picked up a massive thud as the ship hit the bottom. So they knew where the ship was. And when they found it, this is a model of it rather than the actual ship, largely intact, but one of the afterthoughts, which was putting a higher accommodation block on to get the wheelhouse higher so you could put more containers on the deck, had come off. And what you found was the mast, the name, of course, very useful. And alongside the mast was the voyage data recorder. Now, my old friend Jim Card, who was the Vice Commandant of the Coast Guard, pointed out that many point to the Coast Guard's increased role in maritime security and its move to the Department of Homeland Security as primary reasons for the deterioration in its safety programs. So this was 2015, yeah. And the Coast Guard had been moved from defence to Homeland Security after 9/11. And its focus was now about Homeland Security and not the maritime safety side. This was a US flagship. It was still running with open lifeboats, which wouldn't have been permitted under SOLAS on most other ships. Most other ships by then have had free fall lifeboats. But if you know the ship is sinking and you have an option of launching an open lifeboat in a hurricane, you take a chance on the ship, I guess. But there were a number of things where the ship was really in a condition that was not suitable under the international conventions. And that's really down to the change of priorities. One can see the same thing happening now. Is it all necessary? Well, we have port state surveys to tell us the port state authorities can go on board a ship and inspect it. We always just say you get to the bottom of the ladder and you know what you're going to find when you get to the top. And it's pretty true. But these are some of the things done port state inspections. There's some very corroded bits around a windlass. A lot of oil around engine rooms, which is a fire risk. That's a lifeboat, davit. And you think, well, not a lot of steel on the pulley block. Top left is an air pipe. It's got a hole in the top. It's not supposed to have a hole in the top. It doesn't work very well with a hole in the top. The bottom left, that's the damper that's supposed to close off air into the engine room if there's a fire. You get a jolly good shave off the end of it, but it ain't going to block air. Again, more oil and so forth, which is a fire risk. And then you get to the holes, the duct tape and paint. And duct tape and paint does not substitute for steel. But there's a lot of people who will still use duct tape and try and hide what's underneath. Now, one of the things that the class system does, which nothing else does in this, is because you survey the ship at build and look at the design, because you survey it through life, you get a lot of feedback in your data systems about what you find and what works and what doesn't. And that provides a continuous feedback loop into the way you develop your rules. When you pull that through the International Association, you've got 12 societies who will pull that information. That's good and bad. I've certainly been to meetings there and said, well, we think this is terribly important. And been told, well, it's only one ship, isn't it? We did class around about 8,000 ships. So it's quite a big sum. But if you take along something you think we need to do something about this, and the pushback comes particularly from the societies that are based in shipbuilding nations, which says, too expensive. But that feedback loop isn't replicated in the national administration these days because the survey work is nearly all delegated. But it's something which I think is missing in a lot of regulatory systems, is the tying back of the experience of the actual operation back into the standards. This is what started all this off. A graph which a colleague of mine and I put together, that says 2004, so that must be when we did it, or 5. And it's when we were being challenged about old ships. Now, old ships was necessarily bad ships. And we said, well, is it really? And what we were looking at was the loss rates against the age of ships. And they all looked rather good, really. And we thought, that's good. And so I continued doing that for some years. And I've looked at how the lives lost goes. Every one of those big peaks is ferries in the developing world. So one on the left is a ship called the Donna Paz. It's a Philippine ferry, had the misfortune to hit an oil tanker, it all caught fire, killed nearly 4,000 people. We think it did. We don't know how many people were on the ship. We think it was about 4,000. The one on the right is the Jula, another small ferry. So they're nearly all those sorts of ships, which you can sort of say, well, okay, special cases, but. So that's the lives lost graph. And then this is the extended version of the number of ships lost. And a sort of force-fitted trend curve on. And the thing that latterly, I retired in 2010. And the thing that was worrying me then was, why isn't this heading down towards zero? And why is it asymptoting at something more than that? This says we're always going to lose 100, 150 ships a year. And intuitively, that seems to be wrong. You'd expect it to asymptote to something lower than that far enough in the future. And this clearly wasn't going down much further. There's always a problem. What I haven't got later data, there's always a problem with accounting. And this I've got is fairly consistent because of the source. The later ones is not quite on the same basis, and I haven't quite unscrambled that yet. You always get a problem with the latest years because the losses are reported quite late sometimes. So you have to wait 2 or 3 years till you get the final figure. But I always had a theory that you were never going to get further than that because there was a level at which the human error took over. And there's nothing you could do with standards of design, construction, and so on to beat that. No matter how hard we tried. And the autonomous ship was always, it gets rid of the human error. And you think, I think it just moves it. So I reckon when we get down to that, something's been happening over the last 250 years, which is probably for the good. And we can actually maintain a global trade system with something like 130, 140 big ships out there, bigger than 100 gross tons. We couldn't live without it. I heard someone the other day tell me that, well, all your bananas come by aeroplane. No, they don't. You imagine. Very little, 80%, 90% of our trade comes in by ship. So I maintain it is a good service. And that's what we've ended up with. And that is taken on the approach to, do you know, Felix? Singapore. Oil tankers unloading at the jetties there, anchorage in the top. So, I rest my case. Any questions? John David?
You said obviously a lot about oil tankers and bulk carriers. What about these giant cruise liners you see these days? Which seem to tower, seem to be more above water than there is below. It's sort of a top low. Yeah, like that. I see now, aren't they?
It's the Titanic, that's the Titanic being run over.
But
Uh,
have they got a brilliantly good safety record? I've never been on one. They frighten me.
the thing that has been looked at more than anything, of course, is fire. And fire safety is pretty well developed. Been a lot of work done, particularly by Ed Gallier at Greenwich, about evacuation of these things in fire. Did a lot with the railway stations and things as well, but we have had things where Scandinavian start, smallish ship, but poisonous stuff coming off when it catches fire. We also had one of the modern cruise ships which had a fire started in a waste paper bin on the balcony. And the fire spread along these plastic furniture and the balconies and on the outside of the ship. And then started coming back into the ship again and went across multiple fire zones. And the design is such that you can fight 2 fire zones and you get into 3 and you start running out of water. So that there are issues around the fire safety, which would personally worry me. We've got plenty of boats on and things these days, they're all enclosed lifeboats. There's a whole lot of things that are much better. So we have had cruise ships run aground. Not many. But we haven't had a serious accident yet. I think people look at this and you think of the risk when you've got 6,000 people on a ship. The sheer cost of that, if something went wrong, is enough to make you pay a lot of attention. At the other end of the market, when you get an elderly cruise ship, I remember dealing with one where the owner had been detained and he'd done a lot of work on it while it was detained without the surveyors on board, so we just introduced them to a different class society. And we had the power. For 20 odd years, I sat on this a subcommittee of classification at Lloyd's Register, and we would look at the difficult cases with the underwriters and ship owners, so the outside people made the decision about whether you would kick things out of class. I remember kicking at least one cruise ship out of class. And then, of course, the cascade starts because the insurance fails, any charters fail because they've got a warranty clause on them. I'm less worried about cruise ships. The ones that really worries me is general cargo ships. The small cargo ships are much more concerned because they do have a pretty horrific record.
Do we have any online questions?
I don't think so.
I have one.
Somebody's come up with a question.
Can you hear me?
We'd be able to.
My question is about the time lapse. I'm a professional naval architect, also retired. About the time lapse it takes to get a lot of this legislation through. I mean, Plimsoll took 20 years from 1870 to about 1890 before load lines became compulsory. And nothing seems to have changed since then, really.
The question was about the timelines as how the regulations change in time in relation to the amount of time it took for Plimsoll to get the basic things. Are we quicker or are we slower?
Generally much quicker. It depends what you're doing. When the Costa Concordia rolled off of Italy, there were changes in particularly the cruise industry within a year, I should think. You know, you can change things quite quickly. With the IMO ones, there are rules about how many people have to sign up to a convention before it becomes adopted. The adoption rate is becoming much quicker. Been a lot of pressure on forcing those things through. And a lot of it is about, we don't really want to go around with several regulatory systems working at any one time. Yeah, it's a global industry. I want to be able to change the flag from Panamanian to Liberian overnight. So I don't want different regulations in the two administrations. And so generally these things can be adopted quite quickly. Goal-based standards was a huge piece of regulation. I think that probably went through in 4 years. I know I sat through most of it. Initially with IAX and then with the UK.
Okay, I have a question. I mean, you haven't said much about ferries, but when you look at ships, ferries are perhaps they travel very frequently, and people get too relaxed about running their ships. Is that a fair assumption, or is it not?
The problem with a lot of ferries is the vulnerability to flooding, which is the Herald of Free Enterprise Estonia and so forth. I think that's been addressed in many ways. There's a lot of things came out of the Herald, even more came out of Estonia in terms of the stability of ships and so forth. The operational side of a ferry brings in all sorts of things, like we didn't know who was on the Herald of Free Enterprise. There were no sort of boarding passes and things. And so there was a long time before people came to a conclusion this was about how many people were on it. So there's a lot of things around the way ferries are operated. There's all sorts of quirks about the way they're operated on short sea runs. So Dover, Calais, you have a crew that does a few shifts and then hands the ship over to someone else. The question is who takes ownership of the things that weren't quite right? Can I leave it to the next one? But generally ferry operations are a lot safer than they were. If you think back to the Ellen Vannon sailing to the Isle of Man and the Princess Victoria, which sank. But they are more vulnerable because of the roll-on, roll-off nature.
Well, it just struck me that virtually once a year you get a ferry sinking in Indonesia. And
yeah,
there are a lot of them. That's one of the reasons.
Oh, that's the 4,000 in the Donor Paz, it's the 3,000 in the Jula, that they're all in areas which are largely unregulated. And you think that wouldn't happen here. And then we try hard and so forth, but there are inherent limits as to what you can do. And I think one of the things that becomes increasingly clear to me is that the regulatory systems are generally things people don't understand what they're doing. They're a nuisance. But that's because you don't understand how they got there in the first place. With the small ferries, a lot of them come under the thresholds of the regulations. So all the regulations at IMO have strange limiting criteria. These big tankers and bulk carriers now have length in there. But there's an awful lot of what we call paragraph ships, where for ships under 1,599 gross tons, you do this, above you do that. A lot of that affects manning. So, you know, if you get the sums wrong and you were aiming for a 1,599 gross ton ship, and it comes at 1,604, you need more people on it. So there are things where the tonnage drives decisions. When you get onto the ferries, as the ferries go down the food chain, you get older ferries in areas where they're just old ferries, and you overload them. They're very vulnerable. So they're a vulnerable ship type. If you get involved in a collision, they're a problem. Because they're designed to not the latest load line rules, they're designed to the ones before that were replaced for good reason. And one of the problems in the shipping industry is a reliance on grandfather clauses. This was built to the regulations that were around when the ship was built. It's quite difficult with a lot of them to take account of amendments of safety improvements. You can't really go and add another couple of millimetres on the side shell of the ship. So you have a grandfather clause which allows you to stay where you were.
Yeah, we've had a question on chat from Alistair Hughes, which is more, I think, procedural than constructional. Is there anything that covers, for example, the use of tugs, which might have helped in the case of the Baltimore Bridge crash?
That's generally covered by the regulations on a port.
So it's not really your subject.
No, you see, that container vessel leaving London Gateway, it had 3 tugs to pull it off the berth. And by the time it was half a ship length past the next ship down there's 4 berths at London Gateway. And it came out of berth 3. And by the time it got halfway past the ship that was in berth 2, tugs had gone. They were back on the anchorage over by Shellhaven, and the ship was just full away on its own power, running on one engine and one propeller.
Thank you.
Great. Hang on, can I say something? You're the question? I do. I thought that was absolutely gripping. I hope everybody else did. Gripping. What I was interested in was the testing in St. Petersburg. Why St. Petersburg? Are there testing? It's an international enterprise. Are there places all over the world in which they have exciting places where you test your components? Do you then feed your findings into a central database? It's just, it's the sort of logistics of how you do all that. Where do you do it? Do we have enormous testing bases? There's the hydraulic place in Berkshire, but that's not structural testing. I mean, they were testing big bits of stuff in St. Petersburg. Where else did they test it? And what happens if we can't do it in St. Petersburg now?
Well, there were big bits of stuff. Those test specimens would have been half as high again as this room, I guess. So they were quite big chunks of steel, because they had to be, because if you model it, the thing we were interested in was weld toes and so forth, because that's where the cracks come. So you had these big fatigue specimens, and you needed to have places with the facility, basically big fast-acting jacks, to load those specimens up. And there aren't very many of those. In this country, I don't think there's one at a university that could handle that. The Krylov Institute in St. Petersburg could break all sorts of big things. And to be honest, they were very good at doing that. So we did a number of programs with big sections of ships and as fatigue testing, because we were at that stage getting much more worried about the fatigue behaviour of ships. We'd gone past the structural failure part, we're now worried about cracks and so forth. And that meant these big fatigue test specimens. And I don't know of anywhere in this country that could do that scale. Do I think so? So the Krylov was the place that we went to do it. And a lot of those big structural test facilities that we used to have long gone because they were nationalised industries over. So you might have done some of those at sort of central electricity labs and things, had some big facilities. But large scale test facilities were largely gone. If we wanted to do towing tank tests, increasingly it was in Wuhan, Marin, the Netherlands, not in Berkshire. Wrong sort of tank. We built a tank at Southampton, which is quite good, but it is past all that. But the Derbyshire tests on the hydrodynamics was done in either Wuhan, I think, or Wuxi, or in Marin. Because what you were trying to find there was a better model of the loads, because at the end of the day, you're out there with sea loads, and they're not terribly easy to calculate. Aeroplanes are much easier.
But I mean, presumably all that data gets shared across across the nations.
Increasingly, because you want it to be used.
Yeah, no, I mean,
So you've got to persuade out if you're with class societies. What we did was the big thing with tankers and bulkers was politically correct. We started a group, small group, ourselves, American Bureau and Nostra Veritas, and we set out to write new rules for oil tankers. Common rules for oil tankers. And I got quite heavily involved in that. I'm not fettered with the naval architectural education, so I was an ideal person to do that. And we all had different ways of doing things. And they got different answers. And what we found was that the builders and designers were competing using different rules to gradually get the steel weight down. And I always thought of VLCC a big crude carrier, so 250,000 tons of crude. The steel weight in the hull was about 48,000 tons. And then the Korean ones have got down to about 42,000 tons. And the Japanese ones about 37, because they used a lot more high tensile steel. And, you just cranked it down. And we decided the only way you could stop that, the three of us classed about 70% of the big oil tankers. We said, well, if you all use the same thing, you cut out that competition. Because they were competing on steel weight. With an oil tanker, steel weight doesn't matter, actually. If you do it with a bulk carrier, more steel in the hull reduces your dead weight, and therefore reduces the money you can earn. So we did tankers. The other 7 class societies did the bulkers. We then had to harmonise the 2 sets, and that became the Common Structural Rules, which is about 700 pages of A4.
We've had a chat in from Fred Starr, wondering about the quality of the steel. You mentioned there that the Japanese were getting the weights down by using high tensile steel, but there are still boats that break up. Do they tend to be, as you said, the ones with grandfather rules, or is it just something that happens because of people's carelessness in loading and things like that?
You can certainly break a ship by unloading it and loading it badly. It's a big beam, and if you load it in an unintentional way, you can put some stresses in which are not helpful. We did have the odd case that I can recall of steel that was not quite what it said on the spec, but generally steel is pretty good. The sources now is China's the big shipbuilding nation, and Korea. Japan is fine. The difference with Japan was high tensile steels were not a premium grade, so they were basically the same price per ton as the mild steel. So you use less of it because you pay for the weight over the Weybridge. So the Korean shipbuilders got charged more for high tensile, so they didn't use it. There are still brittle fracture cases, but they're mostly relatively older ships. And they generally involve things like strange bits of welding on bilge keels or something that's really a part of the ship that's quite small will develop a crack style. But there's an awful lot of fracture resistant steel use grade Ds and so forth. So the idea is we don't get too many brittle fractures these days. The steel quality is not a problem. The issue with some of our customers was they believed that the steelworks were so efficient, they were rolling down to the negative tolerance of the steel. They wanted us to take all the negative tolerances off. So that was a huge exercise which showed that actually they were rolling down to the nominal. But it's, you know, the range of thickness as rolled is very much closer to the specified thickness than it ever used to be.
I'll add something else. I got lost a bit. You talked about the Exxon Valdez. You said, oh, we have problems with, you know, local regulations. And you then talked about double hulls, and then you went back to something. This is not to criticise or lecture, just I got lost. So did they stop using single hulls and moved into double hulls, which must have an advantage with strength? And was the Exxon Valdez the first one to do that? So I got lost there a bit.
The Exxon Valdez forced the first move into saying we need to get away from having our bulk oil cargo one steel plate away from the sea.
Right.
So you have a double hull, a complete double hull, double side skin, double tanks, double bottom, double hull. When you do that, the structural engineer will say, oh, I can make it all a bit thinner then. Because I've got the strength, because I've got two plates instead of one. And then you're more vulnerable, you're more vulnerable to corrosion. If you get an oil leak into the double bottom on the side, you can get an explosive atmosphere in the tanks. So you need to put ways of monitoring the atmosphere in the tanks. Because it's not that long ago that we had oil tankers sort of blowing themselves apart because you were cleaning tanks and getting static electricity setting off the explosive atmosphere in the tank. And they had 3 big shell tankers disappeared. And the only reason they knew what was happening was because there were 2 survivors, because they were doing some welding up on the bow of one of them. And they survived and explained that the whole ship just went bang. And that was around when you're doing tank cleaning, you can generate a static with the cleaning machines. And so we brought in inert gas and they're all inerted. Then you just inert the people when they go and inspect the tanks.
Yeah, I think there are more questions. Nobody else? That's okay.
Oh, we go home.
Okay. A very, very interesting talk, and really what became very clear is that this is one of the most hostile environments into which you could put a human designed and built object. And I think that became very clear, and that also, of course, means that regulation and classification, etc., is absolutely essential to make it work. And I was very puzzled when you said bulk carriers over 90 meters and oil tankers or tankers over 150. I thought, why is he saying that? But then I realized that, of course, a bulk carrier gets much worse treatment than a tanker. And I recalled seeing the loading of bulk carriers in Narvik, and it's brutal. It's absolutely brutal.
But that's only the loading. The unloading, the way you get the cargo into a nice pile so you can get out with grabs is you drop a bulldozer into the hole.
The speed at which these flows go into the ship and the way in which the ship moves as a result, if you're not very careful, you can break it very easily. And if it's badly loaded, then of course it becomes risky. So I think that all became very, very clear in an excellent talk. So I would like to thank Vaughan in the traditional way. I hope there's some people clapping at home, because otherwise it will not be very loud. Thank you very much, Vaughan.
Thank you, sir. There's not enough in the nuclear transactions about regulation generally.